Welcome back. In today's video, we are going to take a look at the pseudocode for merging a single array. Previously, we studied how we can merge two already sorted arrays and merge them into a new array. But today, we are going to sort an unsorted array, and we will merge this into an already existing array. So, let's dive into the topic. We have to sort this single array using basics of merge algorithm, which we have already covered in previous video. Our first important step would be to divide this array in half. We can do this by dividing the sum of the starting index and last index of the array by 2. Here, we will ignore the value in decimal. Only the integer value will be taken into consideration, because there is no such index like 3.5. We got that index of the array, which is dividing the array into half. Now, we are going to make two arrays, just like there were in previous video. Array left and array right will be our two arrays that will store the left half elements and right half elements in respective arrays. So let's see how we can sort this array using merge algorithm. First of all, we have to initialize a function named merge, which help us to sort out this array. We will take array A, starting index of this array, and ending index of this array as an argument in it. Now to store the middle index of array A, we will initialize a variable named m with integer data type. To calculate the middle index of array, we have this formula: starting index of the array plus the ending index of the array divided by 2. Here in this case, it comes out to be 3. Now we will initialize the array left. The size of this array here is 4, but we have to find a general size for not only this array, for every array possible. This general size for left array comes out to be middle index plus 1, which is true for every array. Now we have to copy the left half elements of array A to the left array, which we just made before. We will initialize a pointer k for array A so that we can access the elements of the array A. For copying the left half elements of array A, we will initiate a variable named x, which will be storing the indexes of array left. Now we have to run a for loop starting from index 0 up to the middle index of the array, and each time we will increment the value of k. Here we can see how copying of element is performed. Now, we will initialize the array right, which will store the right half elements of the array A. Here also, we have to find a general size for every possible array. We can see that to find the size of the right half array, we can subtract the ending index of the array with the middle index of array A. We will be left over with the right half elements of the array A. So our general size for every possible right array comes out to be j minus m, which is nothing but the subtraction of the ending index of the array A minus the middle index of the array A. And similarly, we will copy the elements of right half array to this array, as same as we did in left array. Now, we are left with the two arrays. On these two arrays, we will perform the same steps that we performed in our previous videos. So I will suggest you to first watch that video then only proceed. You can pause the video here and then continue after. We knew from the previous video that the merge algorithm is executed many times, and the comparisons are also done enough times. So, how can we inform the computer to stop doing comparisons? Or in other words, we can say that the one of the array is already ran out of the elements. For this, we have to make this code executed in a while loop. Inside while loop, we will make a condition like this: if the size of the left array is greater than or equal to the middle index, and if the size of the right array is greater than equal to the last index. If one of them is false, meaning that out of these two arrays one have finished, so we will terminate the loop. And after that, we can continue copying the leftover elements of the left out array to the existing array. So, in this way we can merge and sort out array at a time into the existing array. In next video, we are going to take a look at the basics of merge sort algorithm. So to watch next episode, I will suggest you to cover this video and previous video for better clarity. Till then, keep grinding.